All right, number 9. And that's all she wrote. So this and that Ken puzzle at the end. A teacher uses a quiz as a diagnostic to predict performance on an upcoming test. The data are listed below. All right, so this is we're talking residuals here, and so again, calculator intensive process, and really a lot. I mean, it's the last problem, so you already know. It, this entire course is calculator intensive, so I don't have to say it anymore, I don't think. But we're going to put our information here in L1 and L2. So let me get rid of my key press history so I can actually see. So stat, edit. I'm going to clear out L2. So highlight L2, hit clear and enter. And I'm going to highlight L1, hit clear, also enter. And then start typing in some stuff. All right, so part A says find the regression equation for this data. We're actually, I'm asking you to do that, but you'll notice in all the follow-up questions, in no way do we actually make use of that information. And it seems like a throwaway step. However, it's the most important step. Another most important moment. So stat, calc, for, in this instance, because we're not actually doing anything with that regression equation, it doesn't ask us to predict anything, we can just go right to calculate. So I'll make a note of that. So we're leaving this blank. Because no predictions. They're not asking us to find y when x is something or x when y is something. All right. So calculate. So we have that now. Wonderful. I'm only asking you to do this as a public service because nothing else is going to work correctly if you don't do this. You'll get information related to the last time you did StatCalc 1, right? And so if you write the regression equation, y equals 4.309 x plus 50.818. If you write the correct regression equation here, then I'll know that at least you were working with the right data when you did everything else after that. If you write the wrong regression equation here, then I'll know that everything you did after that was based off the incorrect data set. And I'll even know what data set it was. Bless you. Because when I'm gonna go optimistic here. On the off chance that you screw this up, when you write the regression equation here, if it's incorrect, I guarantee it's going to be the same equation as the one in the previous question. because what you will have done is you will have typed in this information, but never have run the regression, and therefore you don't have a regression equation to work off, and so you think it's the same as the last one. All right, or you just never type in new data, which is even worse. So now that we have that, we can go into our editor eventually. Go to L3. So right on the L3. Must go on the L3. Once you do that, you're going to hit second, stat, and you'll see the one that you want. It's resid. And then hit enter. All right. So they're on the L3. You want to have a blinking cursor in the bottom of the screen, so you want to hit enter. Blinking cursor bottom of the screen. Second, stat. That brings you into the list menu. Gives you all the list options. You see the one that says resid, residuals. That's going to take all the relevant residuals and put them into your column L3. Enter. Error? All right, so let me do it again in the hopes that maybe errors will go away. All right, so stat, so your data's in, stat calc, option 4. You can ignore store regression equation. Hit enter on calculate. Now you have this stuff. Go into stat, edit. In L3, make sure, not in the first cell, make sure you go on to the L3. So highlight that L3. So up arrow to the column heading, hit enter. Second, stat, option 7, and then hit enter. All right, so these numbers have to get in here. Approximates are okay, because we're, you know, if you're in the right neighborhood, I'm going to assume that it's pretty correct. So point, out of that you have really great eyesight. I'm going to 3 decimals, 0.255, 2.055. Anything that appears on the list itself, I'm not looking at the bottom of the screen, whatever appears like in the list is an appropriately rounded form. So if you wanted to just retype whatever or rewrite whatever the entire decimal is, ignoring any rounding, you can do that. I'm just rounding to 3 decimals as I go, but you can take a few liberties here. I just want to get the rest of the display here. Now that I could have gone to 2, I guess, but 291 negative 3.6 and then 6.09. I'll just write what I see. All right, so that's the hard part of the problem. Everything else is pretty easy by comparison. There is the calculator approach for coming up with the graph. I don't know how valuable it is here because all it's going to do is create a scatter plot comparing x against your residuals, at which point you still have to plot x against your residuals on the paper anyway. So kind of a waste of time to look at it on the calculator. Maybe as a checking mechanism that would be all right, but here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are our X values. And again, what I mentioned before is just, you can just label one tick mark. You label one tick mark, I assume that it's the same for everything. Take a look at your residuals, because again, we are plotting the X values against our residuals. The lowest and the highest are what I need. It looks like the highest is 6. Maybe we want to have some symmetry in our y-axis. So I'm going to go up to 6. So 1, 2, 3, 4, 5, 6, and then go down to -6. And then everything is a ballpark estimate. So -0.818, positive 0.87-ish, something like that. 2.5-ish. So like 0.25, -2 and change, like right about -0.4-ish, about right over down right in the neighborhood of somewhere up right about a little bit more in the dimension. And then we have a positive 6-ish. So right about All right, very, very rough. That's all we're looking for. We're not looking for too much precision here. If your points are anywhere in the neighborhood of where they ought to be, you're going to get credit. Again, I'm more concerned with things like labels, scale. You should be in the general vicinity of your answer, but aside from that, I'm not looking for much else. Because again, beyond that, computers will do the work for us. Does the residual plot show a linear relationship? Well, it helps to know what it is about a residual plot tells us anything. So if the residual plot shows data scattered with no real pattern, then linear model is a good fit. All right, so that happens here. So does the residual plot show a linear relationship? Yes, it does. And how do I know? Because of all that crap I just said. All right. I forget who I was talking about this last time, but the question was, how do I know if there is a pattern? And my answer was, if you have to use your imagination to see a pattern, then there's no pattern. All right? It should pop off the paper at you. All right? Here, I mean, you can kind of blur your vision and stand like 100 miles away and look at it and say, yeah, I can kind of see how it looks like an exponential function. That's not a pattern. All right? It's like, that's clearly a line. That's clearly a sine wave. That's clearly a parabola. That's a pattern. All right. If anything other than that emerges, then not a pattern. Therefore, linear relationship is a good fit. So linear model. On every test, I always pop in a Ken bonus opportunity. It's a little puzzle, usually worth 2 or 3 points, depending on the difficulty of the test. If the test is really hard, 3 points. If it's not too hard, then 2 points. I always start off with a 4x4 puzzle just to kind of give everybody an opportunity to wrangle some bonus points the first time out. So, the rules of the game, it's kind of like Sudoku in that you can't repeat values within any row or column, but you also have to satisfy the mathematical operations that exist in each bolded region. You zoom. Let me go to 200% and bring it in a little closer, maybe even 300%. All right.